So we can start whenever you want, I think.
Okay, guys, thanks for coming. Our next guest has been a sysadmin network architect, and he's now a puppet hacker, puppet master. He's been working for Red Hat for 9%.
Not quite a year.
Okay.
Yeah.
So it's a pleasure for me to introduce James.
Yeah, James. Just James, purple idea. Hi everyone. This is going to be a hard talk. I've been giving this talk since 2013, where someone needed a speaker for a Puppet camp, or Puppet Conf, or mini thing, whatever. And so I put together a bunch of Puppet hacks that I had been working on and stuff, and I showed it, and all the Puppet guys were like, "Can you swear? Are you allowed to swear or no?" Some. I won't try to swear. So they were like, and it scared everyone, and since then I haven't been allowed to give this talk because it's too hard. And the Puppet people have said they're like trying to do more marketing and stuff like that, and it scares people away. So anyways, I work at Red Hat now. I work on advanced config management problems, distributed systems, things like that. And I try and push the limit of what you can do with Puppet. Now, not everything I show you today is something you want to necessarily directly transplant into your code, but I'm showing some techniques, and for me, it's been a very good research platform to show you what you could do with config management. And some of these tools and techniques should probably be baked into Puppet core, but just to prove that they work, I've actually built things on top of Puppet. I'm going to sit down so I can actually type. There's going to be a lot of demos. If you have questions, let me know. I hope this goes well. There's a little internet problem, which is not great, so hopefully it won't cause too much disruption or slowness, but we'll hack through it. Any questions? If you've not done Puppet, by the way, who's not done any Puppet at all? Who's done a lot of Puppet? Who's done Puppet at all? You know what Puppet is, right? Okay. So it's going to be heavy in config management. A lot of these techniques, as I said, are Puppet specific because I've implemented them that way. But you could port these techniques to Chef or other tools. So I'm James. I write this technical blog where I've written about all these techniques, or most of them. So if you want more resource and reference and code, have a look. I'm Purple Idea on Twitter. So as I said, I work for Red Hat. Work on config management stuff. And so why are we going to do all this? Why? Because Puppet hacks, right? Come on, wake up. I know it's early. I'm really tired too. But so how are we going to do this? It's going to be hacks all the way down, or puppets all the way down. Turtle reference. And how I'm going to do this? I'm going to show you some examples. That was loud. Have you seen this? Muppets, puppets, I don't know. So the first thing I'm going to do is, I can close this. I like the music. So, can you see this okay? Yeah. Okay. So I have this Oh My Vagrant environment, and I'm just going to go into the first machine. So this is all running on my laptop, which has a paltry, very small 8 gigs of RAM and kind of sucks. But I'm going to do my best, so it might be a little slow. So I just need to actually... So I actually am just going to run Vagrant Provision. I have a Puppet Master running on my laptop, and we're just going to push some code to this machine. And then I'm going to show you how this works. So you can actually download all of this stuff yourself and run it at home if you really want, or after this lecture. We've got a lot to go through, so hopefully the internet will behave and we'll get there in time. So if you haven't seen a Puppet run, what actually happened is Puppet is syncing down some stuff, syncing down some code, and it's going to put it on the machine. And actually, all right. I'll do this one in the background. So I have here a little Puppet thing, and I'm going to actually just run this Fibonacci. I've actually written a Fibonacci series in Puppet. And what happens when you run it, so Fibonacci is a recursive function, and it builds on successive iterations of previous things. So what you actually see here is the code, and I'll show you, you can look at the code on your own. It actually goes through and solves for one value of the Fibonacci series. And if you run it again, it will actually take the first stored value and build onto that again. But to make this a little, and you actually need multiple Puppet runs. So it's storing it in a file, loading in that value. And if we look in /temp, you'll actually see that as I run this, more and more files are going to appear. All right, so I run another one. You can see the Puppet code running through. And right now, and one more file appears. And the values are actually here. So the Fibonacci function for 3 is, the answer is 2, and so on. But to make this a little easier, I have a little shell script. We'll actually just delete all the things in this folder. We'll actually just run this little shell script I have. And what it does is it just runs that little Puppet script over and over again until it converges on something that is finished. And so it's doing it right now. And just as an aside, if we run, I have a little Fibonacci program to prove to you that this probably makes sense. And there you can see, let's see, number 8, I've set it to do up to 8. So Fibonacci series of 8 is 21. Does that sound right? Anyone can check this in their head? You guys are quiet. Don't be shy. It's meant to be an interactive session. I want this to be live demos. So it's running through. If you see here, the files are slowly getting built. 2 more iterations, and then at the very end, Puppet runs. Now this took 6 or 7 different Puppet runs to converge. So running Puppet multiple times in a manifest, is this a good idea? Come on. I'll pick on you. By the way, I have t-shirts for people to participate, and I have brought my personal private collection of stickers from all around the world to share. So that's just the first example. Any questions? We're going to move on. So who's done recursion in Puppet before? To make sure not to power off my machine. So I have a little, I'll show you some code too. So I've run this little VM. I'm kicking off Puppet, and I've asked it to run my recursive function. And I've picked the value of 42, so I want it to recurse 42 times and see what happens. Is it going to work? This is a live demo, so of course it's going to work, right? And I'll show you what it looks like. And if you look right here, you can see the whole tree of 41 calling 40 and so on. So if you want to see what the code looks like, oops, that's loud, sorry. So in here I have a little thing that kicks it off. That's what I do. And this recursion function is, right here. So it's actually very simple. This is the type. You start off with a count. I'll give a notify so you can see what's going on. I'll subtract 1, and then I'll call it again with a new name, which is count -1. And this works. Why would you want to do this in Puppet? Anyone? Any reasons? Is there any reason at all? So actually, you probably never want to do this. This is not a very useful technique, but it is an example of iteration, because Puppet doesn't, until recently, have a native for loop or iteration operator. So there's lots of forms of iteration that you can do to write code without actually needing a for loop, and that's actually a feature of this declarative language. So this is one way you can do it. So that's what it looks like. So I have another machine, so I'm going to number 2. So the next is a technique called exec again. So, excuse me. When you are writing Puppet code, your Puppet code or whatever config management code should ideally run, and in one shot from a machine that you just provisioned that's brand new and clean, doesn't have anything on it, it should get fully installed, fully configured, and after one run, it should be perfect. Okay, so the second run you do, nothing should happen because it's idempotent. Have I lost anyone? Any questions? You're all very quiet. Don't be so quiet. Do I have to throw t-shirts into the audience? It's not like with the t-shirt cannon. But there's actually some situations when you need Puppet to run more than one time and it's not a bug in your code. It's usually a bug in your code, but there's some situations where it's not a bug in your code. Who can give me some example? Oh, you don't get to answer it. You're too smart for this. You're no offense. You know this stuff and you've seen some of this stuff. But did you hear his answer? Yeah.
Well, I was gonna say I have a situation where you're orchestrating things across multiple machines.
Right.
I play something on one machine and then I'm waiting for something to finish on another
Right. So multiple machines. This is the problem. You can come get a t-shirt if you want. Come after, grab one. The one objection that I have is that you use the word orchestration. So when we're talking about orchestration, orchestration typically means central orchestration. And one thing I want to point out is none of the techniques I'm using here at all have any central orchestration. It's all entirely distributed, entirely decentralized. And the advantage of something that's highly distributed and decentralized is, think of an advantage. What's it? No single point of failure, right? You might be able to scale it much, much further too. The disadvantage is you've got to write all these complex algorithms. But we can solve this problem, and code complexity probably gets easier too. So what I've actually done is if I'm building a multi-machine cluster in Puppet, what I actually can do is detect when there's more work to do because I'm waiting for someone else, and then it can run Puppet again on itself. All right? So I'm going to show you this. So I think this is 2. This is a little vagrant command that I'm using called vscreen, vagrant screen. I'm going to talk about this in my other talk. So let's look at what's happening here. So this is my machine. So what I do is I've included this little function here, and I have this temp foo file that has a certain content. Well, I'll just get rid of this too. So if we go in temp, something is there, okay? But I want to trigger this, so I'm going to just edit foo. Hello, devconf hackers, right? I save that, and now I'm going to kick off Puppet again. I should have actually... So, I'm kicking this off. Okay, you can see the Puppet run. And if you look right after it finished running right here, it's automatically kicking off another run. You see that? So the way this works, did anyone miss that? It's okay if you did. This is hard stuff and I'm going fast. So if you didn't get this, ask me now. Okay?
So
yes?
It would sometimes be helpful if you could say, I mean, you were hopping between the streams and shells so fast.
Right.
So where are you looking at what?
Fair enough. I hop around very quickly, you're right, and I'm sorry for this. So here's what happens. So I have a manifest that says, for some reason, I'm going to detect that I need to do more work. That is right here. Okay? So I will have run this notify. This notify is a special program. It's a type-in function. It's an exec. And what this does, when it gets executed, it runs a little Python program. That Puppet, so Puppet runs that Python program. The Python program says, hello, I'm a Python program. First thing I'm going to do, I'm going to double fork. So it forks so that it gets away from the parent Puppet process. Just before it disconnects, it actually saves some information about the parent, namely what command line it was running with and stuff like that, what PID it had and so on. After it double forks, it will actually watch the parent process and wait till that Puppet run finishes. Right? The Puppet run can finish because that guy's not part of it anymore. After the Puppet run finishes, it says, I've now detected that you are no longer running. I will wait 2 minutes, or not, or wait some time interval, and then I will fork off a new Puppet run on that same machine. You like, this guy just like smiled. He's like, oh shit, I know what he's doing. That's madness, right? So that's really what you're doing. Now this is definitely a hack. It definitely is a weird thing to have in Puppet, but unfortunately to build distributed systems and to prove how they work, in this sort of system you need this technique. It's not possible without it. Actually, it is possible without it. The other way is you boot up your 10 machines in your cluster, they all run once, you wait half an hour, they all run a second time, and 3 days later it's finished. Yes, question?
Is there any way to do it that isn't time-based?
What do you mean is it time-based?
You said it would run again in 8 minutes, 2 minutes.
Oh, right.
I want to see that the output is something specific.
Yes, but we'll talk about that later. So the question is basically, is there a way to do this that isn't time-based, waiting a timer? I'll talk about it a little bit later, actually. Or do I have a word? Can I write on this? Actually, the way you do it, I'll answer your question. Can I? Yeah. Okay, whatever. The way you do it, actually, so I invented this technique for building clusters of GlusterFS hosts. So what happens is you have hosts that you want to self-assemble in a cluster. Can you guys sort of see? sorry, I don't have bigger. And what actually do is they all boot up in parallel, they all install their packages, and then they start exporting data to each other saying, hey, I'm here. And what happens is, this guy says, oh, there's people that want to join this cluster, but it hasn't happened yet. So I'm going to run again in 2 minutes. And they'll all keep doing this. They'll keep running again over and over again until people join the cluster. And they actually watch the cluster shape and see, does it change? So it's actually like a meeting room. So 10 people come in. I say, okay, people are still coming into the meeting. I'll wait 2 more minutes. And then 5 guys trickle in, wait 2 more minutes. And then as long as the graph is still changing, we don't actually build the cluster, because building the cluster is a more expensive operation. And we keep doing that until, you know what, for the last 4 minutes, nobody has joined the cluster. I think now I'm going to build it. And exec again is the tool that gets you there. Now, after the cluster is built, you could still then later resize it at a later point. But it's more expensive to do that. So we want to wait a certain arbitrary amount of time that's reasonable and continue. Okay? Yes?
Okay, one more possibly very dumb question. So new question. This mechanism is waiting for the original process to finish and then trigger a new one. This is on the host, so on the machine that runs the...
Correct. So this is
not
all
on
a
the
single
machine
machine
provision,
thing.
right?
Right. So this is all a single machine thing. We're going to get into multi-machine later.
No, I wasn't. So Puppet isn't it always like you have a machine and you provision another machine with that? So.
Right. Okay. So we have a Puppet master. So the Puppet master is always here and it's not doing anything interesting. So forget about that. For the code that we're actually running, it's running on a certain machine called, foo. And that machine says, I have more work to do. I'm going to exec this thing off, which will cause itself, to run again. Okay. So good question. So that's exec again. Just so it's very, very clear. So in, right? And every time it runs, I'm just writing to this file. So if we want to see it happen one more time, oops. So foo, it changed, right? Hello again. We put some message here. We're going to kick off a Puppet run. Okay? So we're kicking off a Puppet run. Puppet is running. And when it runs, it's going to write a date to this file. All right? We're watching the log on the left. So we see right here, it changed the file back. It wrote a date to the file. But Puppet now has kicked off another run by itself. And you'll see a second date was written. Okay? It's a little maybe tricky to follow because I am flipping around a bit, but if you sit and follow the code, I think it'll be quite easy for you. Okay. So that's exec again. So we have exec again. We have this Fibonacci series that we had to run manually. Let's do the whole thing together. Make sense? So I'm going to boot up machine 3. That's just booting up. This is Puppet run. So basically when the machine boots up, it asks the server, says, hi, can I have some code? The server starts sending some code down to the Puppet client. It runs those facts, and then it puts out the graph. And so here you can see the whole Fibonacci thing running. And right here at the bottom, you can actually see scheduling refresh of exec again. So the code itself realizes there's more work to do, so it's going to say, please run again. So that finishes. So the first Puppet run that I started kicked off, and I'm going to log into the machine. Hope this works. I think this works. Right. Okay. And I'm just going to log, follow the log, and you can actually see that Puppet is running by itself right here. If you want some proof, you can see that the Puppet agent is getting kicked off. All right? And after it converges in 8 iterations, you should have a value. I think in here, you'll actually see the numbers appear. So it's running again. Numbers are appearing. Number 5 appeared. And gradually it's doing the same thing, but this is all running without a shell script. Remember that first shell script I showed you at the beginning? I'm not doing any of those hacks. This is all in the one machine. And what do I have here? I'm just going to... Okay, and then at the very end, you'll see right here in the logs, f of 8 equals 21. Is this very boring, or is it way over your head, or like, what is this guy showing us? Any questions so far? Don't be shy. You got a question?
So are you referring to the Puppet-Gluster thing? That's how you exactly do it.
So that's one place I use this technique.
I use Puppet-Gluster and it didn't work for me.
My module?
Sorry?
My module?
Yeah.
Great.
We spoke original and
Okay.
it didn't work out.
Yeah.
And Deepak, by the way, if you remember.
Okay. Hi.
So I was trying to understand. So in the cluster use case, yes, there's a concept of creating the cluster.
Right.
So you actually go as more and more hosts are coming in, you're creating the cluster and
Yeah.
you have propagation there. So I'm just trying to understand when you do exec again, how does that help you doing the, I mean, how does it know? So are you just saying that as long as more people are getting added to the peer list,
Yes.
you keep doing exec again?
Yes. So it's a very good question. I will show an example of this a little later on, which I think might make it a little clearer. But if not, ask me again because we'll have some time at the end. One other question also?
I just wanted to know if it's possible to have the files in some repo to have a look.
Yes, it's all online. It's all on GitHub. It's all there. Everything. I publish all my code.
Okay, and what's your GitHub name?
Puppet-IPA. Puppet-IPA. I wrote it down. So the point is, this talk is actually not about specific things about Puppet-Gluster or Puppet-IPA or any of those projects. It's about techniques and tricks and logic about config management systems that you need to build advanced modules. Because what I really want to do is close my eyes, press enter, or just rack servers and have everything automatically build and be elastic and magic and so on. So that's, and actually just for fun, if we actually just run, that was 3. If we actually kick off Puppet run again, what's going to happen on this machine? What?
A single run.
Yes, a single run, exactly, right? It's already done the convergence, right? So it has all those stored values memoized, not memorized, memoized, and it should finish very easily. So we run it, and as you can see in first run in 1.38 seconds, f of 8, 21. Cool? All right, we're going to move on. So I'm going to kick off this new thing. So the next feature I have is a simple timer. I'm going to show you how this works. So we'll try and catch it quickly. So we're just booting up the Puppet machine again. Okay, so I have this code that kicked off a little timer. And the timer, if I run it again, show you what happens. So this is my timer class. And what I do is I run an exec that starts a timer, and I have this run once thing that runs an exec only once. And this last one here will only run after a certain amount of time has elapsed. And the way it does that, as you can see, the second time we ran it, nothing happened. And every time we run it, it's going to check, is it time for me to run this new exec? And if you're within that time bracket, run it now, So it ran the initial exec, it ran the next part. We'll run Puppet again. So this is me just running Puppet again manually to see if it's going to trigger, and nothing's happened. Right? We'll run it one more time. As an aside, why would a timer be useful, by the way? What could we use this for? So we basically want some action to happen after a certain time interval. It's hard to come up with an example until you're writing code and you want something to happen.
For example,
What? Yeah?
For example, if this is some difficult task to run,
Right.
then you don't want to do it when someone else is doing something with scheduled end or something like
Yeah,
that.
that could work. A difficult task is an interesting thing. I'll tell you why I actually first built this technique. I was building a Puppet module for DRBD. Has anyone ever heard of that? Maybe. It's a thing that lets you share a block device on two machines. So you build them up, and when you're first building your cluster, when it's synchronizing, you want the synchronization speed of the data to be really fast, because you want your cluster to be up and ready really fast. But after the cluster is built, you want the synchronization speed to be less, because you don't want to interfere, you don't want to take bandwidth away from the normal sync process of data. So what I actually do is you build your cluster, you kick off an initial run of synchronizing at a very fast speed, and you wait an hour, or however long you want. You can even do some math about how much data is there and decide what to do, how long to wait. And then after an hour, Puppet will say, oh, we've been running for an hour, I'm going to slow down the synchronization speed so that the users have more bandwidth. Does that make sense? And we'll just finally run it one more time because it's been a few minutes. So nothing has happened the last time except for a little message. And as you can see now, the timer has elapsed and it execs successfully. And as you can see in the message, you see the timer message. Okay? So how can we make this better? Because I had to run it manually. How can we do this better? Pardon me?
I said exec again.
Right. So this is built into the timer class, right? So we set up our timer. We say, we have a few different things. We have an event that says run once. Oops. Just get this running. So we have an exec that says run once, and we have a timer that says I'm going to expire and write to the log again. So what we also do is we automatically say if the next timer is going to happen in 3 minutes, just run an exec again that goes off in 3 minutes, so that when this Puppet run happens, it'll spawn a new thing that's going to wait for 3 minutes and then run Puppet. And as long as you're basically 1 millisecond before the timer is going to go off, then Puppet will run and it will work perfectly. Right? If your exec again goes off before the timer is ready, it wouldn't make sense. But the code basically waits 1 second longer than needed, so you get an approximately accurate timer. Right? This isn't millisecond accuracy, it's accurate within to a few seconds. So, based on the load on your Puppet master and so on. And let's see it work. So it kicked that off. Oh, this is the wrong machine. So the initial timer went off. See if we can log into the machine in time to catch the message. Okay, so that's running. And if you watch, if we actually grep for Python, you'll see right here that I have this Python process which is spinning in the background. It was called with a timeout of 90 seconds. And in 90 seconds, if we watch the Puppet log, is it boring watching logs all day? So this is the file, and that Puppet thing, the Puppet code, the timer that's going to run is just going to write the date to the file. So I can prove to you that this is actually happening. 90 seconds is a long time, isn't it? I'm going to just boot up this other guy. Just trying to boot up the other machine. it just finished, and actually you can see now Puppet's running, and the timer has added the message to the log. Okay, fully autonomous timers. You don't have to worry about it. Using it's actually quite simple. You just have you use these classes, and it looks a bit messy because they've got all this code in here. But if you look at it on your screen, I think you'll find it very easy to understand. And I have at least probably one blog post about this. Any questions about the timers?
I have a question. The define types that you use in your class.
Yeah.
They are in Puppet generally, in Broken.
Correct. I've built all of these.
Yeah.
There's no built-in timers or anything.
Can we see the definition of those defined types?
Yes. Every bit of code I write is all open source. 100%. You can download it right now with your laptop. If you have Git on your phone, you can clone it right now. Actually, this internet's a little slow, but it's all there.
Where we can find it?
What?
Where we can find it?
Right here.
On your GitHub?
Yeah.
Okay.
If you look at my blog and the GitHub, you'll find articles and the code. Want to see this? LibreOffice has this thing that when you have a video slide, it puts your volume to max. So I showed you the fancy timers too, right? This is the next thing, Asylum Town. This is actually a very small, simple technique. It'll be a little relief for you maybe. So I'm going to. Is it this one that's next? Let's see the code. Oops. So here's the counter. All right. So I'm going to boot up this machine. I want you to tell me what happens in the Puppet run. So if you haven't looked at Puppet, don't worry about it. So this is Vagrant talking. It's contacting the Puppet server, which I have as a Vagrant VM. It's saying, can I talk to you? It says yes. It syncs over some facts. What time does this talk end? Does anyone know? Yeah, set a timer for it. Oh, pardon me?
11:20. 1 hour.
1 hour from now?
Yes.
Oh, okay, good. So we can slow down a little bit. Okay, so I ran that, and just to get rid of all the stuff that happens just once, I'm going to run it again to make it easier for you to see. So it converged the first time, so you should probably see very little stuff actually happening. And so what is actually I cheated because I have a notify message, but what has actually happened? What do you see? Oh, you can all read. What do you see? So it's the machine 6, notice. This is a little notification message. It says the value is 1. Okay? Notify does not run code. It only spits out a variable. So I'll run it again, see if you tell me what happens. Any guesses? No, I've scared these people. I'm really sorry. I've scared a lot of people. So the value of 2 has actually gone up. But where's the code that caused the value to go up? Pardon me?
The number of run Puppet.
Number of run Puppet? Well, I mean, every time I run it, this value seems to be going up. But for the value to go up, there has to be some code like the exec that is running to increment the value. And so where is that code running if it's not running here? I don't know, master. Nice try. That would be, if I saw you do this code, I would fly to Finland and get mad at you. Pardon me? It's not stored configs. It's actually, it's kind of a dirty hack, but there's a reason I'm doing it.
Question is, where is the counter value stored?
Right. So where's the counter value stored? So I'll give you some hints. So the counter is actually, I'll even show you the counter. That. So if we go, so the counter value is right here. And just to make it easier, if you run this little function here on that file, you'll see that it goes up. Now the question is, I'm making this increment, and actually the value that you're seeing is just a fact. So I have a fact. If we run this fact, the fact will just read in the value from that file. And that's what I'm showing. So I know that the fact is changing every run, and I know that you can't see any code running, and I've also showed you the code on this machine that increments the value. So where is the code running?
While you're invoking factor?
No, it's not. Well, if it was factor that's running it, and I run this, it should go up, right? So let's see if it goes up. Nope. So it's on factor. Nice try. There's another T-shirt prize. Yes.
I think it was
Factor. It's not factor. You have one? And it's actually it's bad if it's factor because you might run factor a few times yourself.
So it's function.
It's not a function. It's sneaky. It's sneaky. I'll show you. So, the code is actually right here. So I have an exec, which, if it fails, just echoes a message. But the actual increment is in the unless. So every time Puppet runs, it does a check, right? Is it okay to run this exec? Yes or no? And as long as this is working, it's never going to run the exec, so you'll never see any messages. But as a side effect, doing the check is actually causing a side effect to increment the counter. All right? So it's a little dirty trick. Like if you were to run this with noop, with no op, it would actually increment the counter. So if you're depending on a counter that is monotonically increasing and doesn't skip or something like that, this would probably be a dangerous technique. But if you need a counter that always goes up every Puppet run per machine, this is how you do it. And you don't want to make noise because every time you make noise, someone's going to get logs saying something has changed, so your machines won't look like they've converged. And this is bad for infrastructure. So that's why you want to have it silent. Any questions? You like this? Cool. There's all these techniques that need inventing. We need hackers to invent these techniques. All right. Yeah? Question?
The question is, why Puppet doesn't do this? I see it.
That is great. You got a T-shirt, sir. So repeat your question louder.
So my question is, if this is something usable for multiple purposes,
Yes.
why those primitives don't exist?
So, this question, if you can hear, is why don't these primitives exist in Puppet? Why aren't these built-in native things? The truth is, in my opinion, Puppet has stopped innovating. They have other problems. They have to worry about making money. They have to worry about basic parser things and language issues. They've got a lot of stuff to do in their product. And these aren't priorities for them. 80% of people are building very simple manifests, install a package, set up config file, and start a service. You're all experts at that already. I just explained you how to do it. It's easy. For the more advanced things is what I'm trying to work on. So I'd love for them to take some of these techniques and build them in Puppet Core, if that's possible. It's unfortunately out of my hands. But it's a very good point. So if you like these techniques and if you think they can be useful for building distributed modules, then maybe we need a tool that does this natively. So I'm going to move on. So that's the counter. And that's how it works. So the next, where is that code? So that's the silent counter. The next thing is a finite state machine. Who knows what this word means? Because if you haven't done some CS classes or something, you don't count. You're not allowed. You know.
I'm silent counter.
Buy this guy some ice wine, please. So this is going to be answering your question. If at the end of this you still have your question, ask it again. So a finite state machine is just a bunch of circles with graphs, with edges to connect them all. And you might be able to move around this graph and do some stuff. Here's one. Here's a graph that you might look. This is just an enthalpy graph. So it just basically shows you that if you have something like water and it's in a solid, it's very common to me. I'm Canadian, so we call that ice. And if it goes towards a liquid, what do we call it? It's melting. Okay. But if we go the other way, it's a different operation. It's freezing. So based on the direction that we're going, based on the hysteresis of the system, it has some memory, and we might want to do different things based on which way we're going. All right? And so I've built this in Puppet. Oops. So we're going to go right over here. I'm going to log into the Puppet Master. Put that over here. And this is 7. So I'm going to just kick off one run. Oops. Yeah, that's good. So I have my, this is pushing 7. So I have just an example finite state machine for transition. And we said it's a transition of water, and it's going to be a liquid. Let's let it run. I have just 2 examples left. I have this one, then I have a really brand new, totally untested example to show you right after, and then we'll review some stuff and ask questions if you have. So I'll run it again just so it's clearer so you can see it. Okay, and if you can see, nothing has happened, right? It has run the previous time, but right now, apart from a small SE Linux bug right here, in my code, not in SE Linux, apart from this small unrelated thing, nothing is happening in the code. So what I'm going to do is I'm going to change it from liquid to a solid. We're going to save that on the Puppet Master and run it again. So we went from liquid to solid. What should we see the action to be? Frozen. Well, so let's see if that's the message we get. Now I have just a table that spits out a message, but instead of spitting out a message, you could have some action. And if you look right here, you have a message. The phase transition of water from liquid to solid is called freezing. So it seems to work. Let's test it again. So if we go from a solid to a gas, we'll run it. I'm going to show you my code at the same time. Is it in here or is it in here? So here's the code. So to actually do the deciding, I just have a table, right? It's a lookup table. But this is just an example. It could be something more complicated. So here the transition from solid to gas is sublimation. Is that right? Gas, sublimation, so it looks good. We can go from a gas to, so let's go from a gas to, where are we now? We're at the gas. So let's go to the plasma.
Can we try from solid to plasma?
Yep. I'm gonna do exactly that. So we're gonna go from the gas to the plasma, right? So oops. Where's my code? There we go. So we're in a gas. We're gonna go to the plasma, right? And then a gentleman asked, well, what if you go from plasma to the solid? What happens? And that's exactly what I'm going to show you. So, now it's to a plasma. That was ionization. And now we're going to say, you know what? We're going to try and trick you. We're going to go from a plasma to a solid. And is there a way to get there on this machine? No, it shouldn't work. So let's see what happens if we run it. It should set my laptop on fire, I hope, right? Or we beat science. And as you see, there's an error. It won't let you do it, okay? So if there's a phase transition that you have not mapped out, it will error because it's undefined. And this is actually either you want to do something or you don't. you might have a message for the system saying, hey, you haven't thought about this use case. Why do we care about these transitions, by the way? Why is this a useful technique? The reason this is a useful technique is the following. Let's say you have a cluster of machines. And there's something that's broken with one of your machines. How do you fix it?
You want to reconfigure them.
What?
And, for example, switch configuration from master server to slave server and slave to master.
Yeah, I mean, yes, but you're being too specific.
Automated failover.
Yes, this is valid, but the more, I'm going to back up and make it more general. So the problem is, let's say you have a bunch of servers, and one day something is something is broken. Something is in a state that is bad, right? The mail server is not working. So
you can define that for performing some kind of task.
Yes,
there must
exactly.
be a specific state.
Exactly, right? So if you can detect the state, when you're a sysadmin, you go to a machine and you run a bunch of commands, right? PS, is this running? Yes, no. Is this message in the log? And so on. And you basically run a bunch of steps, and if a bunch of commands, and if all of those are true and produce some value, you think, the problem is the mail server is broken, or this is happening. And if a certain set of commands is true to the sysadmin, he or she then says, okay, well, to fix that, I run these set of commands, right? So the states are the current state you're in, which you can detect with scripts, and the transition is the steps you do to fix something. So if you have this technique in a config management system, you could, in theory, every day something is broken.
Self-healing.
Wow, self-healing. You could figure out, theoretically, if you had enough time and energy, figure out what steps you need to do to fix every possible state, and then you automate your life away. Now, doing such a thing is maybe a longer process, but everyone does this for one module, and then eventually we'll have a really dynamic system. Does everyone get the use case? Okay? So this is a simple system, much easier to explain than some big cluster, but I think that and keep in mind, none of this has any central coordination. It's all completely distributed. Okay, so I have one more technique. So this is a brand new technique. I've not shown this anywhere, and I just finished making it work this morning. So here's the basic problem. Actually, let me set this up first. So we're going to close this guy. We don't need that one. So I'm just going to wipe out some machines, because this is going to build a whole bunch of machines, and my laptop doesn't have that much RAM. It's done. So this whole environment that I'm using, and all of this, I'm going to be showing in another lecture today. So if you want to see how I work and how Vagrant works and some tricks and some cool shell hacks, it'll be a much more easier talk to understand, I think, shortly after this one, which you're welcome to come to.
James?
Yes?
Are you in touch with Puppet-Gluster and cooperating with them on this thing that you see as functional missing potential Puppet and you want to implement it, or is more developing it and it's going to solve it from your side?
Right. So he asked, am I in touch with Puppet Labs? I know a whole bunch of people at Puppet Labs, and a lot of them actually like my techniques. The problem is, as I mentioned earlier, there's, let me just keep this off. 3, 4. The problem is they have other priorities, and me telling them, a Red Hat guy, makes it worse now, a Red Hat guy telling them how they should be writing their stuff and how they should be building their things, they're not really interested in hearing this, unfortunately. A lot of them, I know that even Luke reads my blog as far as I know. I mean, I'm known in the Puppet community, but the thing is, I'm doing sort of weird things that I think the future of config management should have, and I think they're still stuck in present day. So, will they get there? Yes, maybe one day, I don't know. The techniques they do and how they get there is an open question. I really don't know. So I can't tell them what to do, but I can publish everything I do, and any of you are welcome to add this into any tool you want, or all the ideas are there. My job is really to prove that they work and hopefully produce some useful modules at the same time. Okay, so I'm just going to run a Vagrant status. Almost done. This is my slow laptop. So Vagrant is a little slow because I have this really complex Vagrant file. Any questions while we're waiting? How much time do I have left? Half an hour? Yeah, good. All right, so these are all good. So I'm going to, so as you can see, I have these 3 machines here pushing 8-A to C, okay? And I'm going to bring them all up. This will take a few minutes. And I'll tell you about the fundamental problem. So here's the fundamental problem. So who's familiar with exported resources in Puppet? And who's not familiar with exported resources in Puppet? And who's afraid to raise their hands in a lecture? Okay. So just a little assert there. Okay, so I guess that's fair. So the problem is, so Puppet actually has a very nice, elegant feature called exported resources. It's my single favorite feature in Puppet. Tons of Puppet I hate, but exported resources are really great. And what they do, very simply, is if you have a machine, this machine might want to tell another machine about some data, about a type. And so what it can do, it can run, and it can say, well, the following type needs to go somewhere else. So he puts it somewhere, in some place, and this machine, when he runs, he can actually grab this information and use it. So it's a way for machines to exchange information. Now, Puppet currently does this with a central master. So there's a central master and a database, and so they all communicate by pushing stuff into this database and pulling from this database. But there's no reason why they couldn't directly interchange information through some sort of distributed key value store, something like etcd or similar. So that's possible, but for the current day, that doesn't exist, right? Puppet doesn't have a distributed key value store, but the point I want to make is it could be fully distributed. And so the problem is Puppet isn't a... the Puppet runs aren't kicked off from a central place. What actually happens instead is that each Puppet agent says, I'm going to run connect to the Puppet master, or I'm going to kick off the run. It's not centralized going the other way. And so if this guy runs and then says, I'm a web server, I want to add my port to the firewall or to the router. So this one will run, it'll export that information, but the router or the load balancer or the firewall or whatever it is isn't going to know about this until this guy runs, right? So for this guy to get added to your load balancer, you might have to wait, in the worst case scenario, maybe 30 minutes for the next Puppet run. So what's the solution? Well, I've sort of given it away. What you could do, yeah?
Start distributed, basically that every Puppet agent is Puppet master at the same time?
Sort of. I'll give you a hint. It's related to the exec again thing. Yeah. So what I actually do is this guy, when he knows or she knows that there's something that they want open, like on a load balancer or whatever, he will first export the resource, and then he will kick off a Puppet run on another machine. And the way it does that is different ways. The way I've implemented, which I'm going to show you, is he connects over SSH and logs into this machine. This guy here is waiting for a connection. And the way it's waiting for a connection is when Puppet had ran on this one, a little Python script will double fork from its Puppet thing and sit there waiting for someone to say hello to it. It's actually the same double forking as we did for exec again. And then this guy, he SSHs in, connects to that little Python program and says, hey, please run yourself again. Since he's waiting in the background, he says, okay, I already know how Puppet was started, and will cause a new Puppet run to get kicked off. So basically, this message goes across and causes it to happen. Let me give you an example of this so it can run while we're waiting. So machines are up. So what I do So these are the machines. They're all up and running. So I have a clustered version of this. If I run this, I'm going to get a bunch of shells on the host. Okay. So, I don't know how well you can see it, but if I type in this little box over here, you can see what's happening. Okay? So I'm kicking off this Puppet run. Oops, I went too. Yeah. I'm just going to check one thing. Okay, good. So over here on the machine, I'm just going to show you that there's no Python running. There's a TuneD thing, but there's no actual other Python running. So I'm just going to kick off Puppet to run once on each of these machines. And this will happen as your normal boot up in your cluster. And what's going to happen? Do you remember? When Puppet runs? Yeah, I heard it. Kick. Who said kick? Who said it? You? Yeah, you both said it. Say it. So it kicks off that little Python server. The one disclaimer: this little Python server is a piece of crap. It was really hard to write this, and if you're good at Python and threading and stuff like that, and you can help me fix this, please do, because it really needs help. And so now each of them is running. It's running the last one, and you see right here, you can see kick off. Oh, there it goes. Here's the next one. It's a little listen class, and it kicks off this poke server on port 1337. All right? See what I did there? Okay, good. and as you can see, it's just a little Python program sitting there doing nothing. As an aside, I have this counter, which is now set to 1 because it just ran. Okay? Now what I'm going to do is I'm just going to kick off a Puppet run on one of the machines. And what I've actually done to prove that this works, I hope it works, is if the counter is greater than 1, then it's going to look at the hosts that exist and poke the next one in the list. So in theory, if this works, so I have these 3 hosts. They're all up and listening. I'm going to poke this one. He's going to poke this one. He's going to poke this one. And it should go in a loop. So you can see the obvious problem with this, right? You could really kind of deadlock or break your system. But I have the counter, so I'm going to say do it as long as you're under 8. Okay? So actually I'm waiting for the whole thing. So we'll kick this off and we'll see if it works.
Where's the list at so it knows which one is next?
The list is actually hard-coded at the moment, but it could be dynamic. But for this example, I made it static just so that it's not, what is all this code doing? But you can do dynamic lists. So the first one's running. And then the second one, so it's first, second, third. Okay? So you see that running. It kicks off. That's it logging in. Thank God this is working. Phew. It's kicking off that one. And if you look at my CPU in the top, it's kicking off that one, and it's going in the loop. And now my machine will heat up and burn in a fiery flame. But as you see, it should keep going. Cool?
Will each run is spinning additional process?
So
going to be spinning additional before it ends, and then
no.
runs ends.
Good question. Hold the question for 1 second, but we'll talk about it. So I poke this one, it pokes that one, it pokes that one, and so on. So now your question, and it's just going to go in a loop. So here's the question, and it's what you're asking about. So when we poke from the client to the other client, how do we want to poke? Do we want to just say poke and run? or do we want to wait for it to finish? And you can look at this as a synchronous poke or an asynchronous poke. My code supports both. So in this case, they're asynchronous. So it says, please kick it off and run. If we ran this same code with a synchronous poke, what would happen? Then it would be what you said. If it was synchronous, it would say, I'm running. Okay, now you run. But he's still waiting for this guy to finish. This guy would say, you run. He's waiting for that guy to finish. Deadlock. Because you can't have more than one puppet running at the same time. So that would deadlock. Now, there are timers and stuff to prevent this. What you should really do is not code something that can deadlock. But to avoid that problem and to make the example simple, it's asynchronous. That's number one. So it could be synchronous or asynchronous. When would you want a synchronous poke? And it's actually why I've made this technique.
Make sure it was successful.
To make sure it was successful? So that's a good point. So you want to make sure that the run happened. Excellent point. And what sort of thing would you want to wait for?
If you want to do some configuration on your that needs some configuration finished on the
Correct. Pardon me?
Maintenance tasks. You have from computers and it's only one node down at the moment.
Yeah.
You update them all one by one.
Well, there's lots of possibilities, but basically the general problem is, how much? Half an hour left? Oh my goodness, that's great. The basic point is, and actually the reason I built this technique is, Puppet-Gluster, for example, when it wants to start a volume, you have to open ports on different machines, like on the client. So if the client wants to start a volume and you want to whitelist every single port, you can say, I want to start the volume, please go open the ports, I'll wait. Puppet will run, it will open the exact ports that that client needs, so nothing else is allowed in. You'll wait till it's open, and then it will mount. Okay? Same thing for closing. You can say, I'm going to unmount and then close the ports. Yeah.
Another question.
Yeah.
Let's suppose that we have Puppet-Master and the agent runs periodically in half an hour, for example, and agent starts on agent is running on node B and starts on node A, and node A wants to node B. So it ends up with error. Puppet agent is already run.
Right. So the script that forks off, the server, is actually smart. So it actually won't run Puppet when it's running. And it's actually even smarter than that because it says, okay, I'm going to wait for Puppet to end. And then if Puppet ends and then starts immediately before it has a chance, like if there's a race, it's virtually impossible. But if there is a race, it will detect that and say, well, someone has just started Puppet again. Even if it wasn't me, it's the same thing. I'm happy. So the code that does this is terrible. Parts are good and parts are bad, and I'll tell you why. Just quickly before this disappears, you can actually see this in Vert Manager. You can see, I'll move the cursor, but you can basically see the CPU load of one running, then the next one, then the third one, and so on, right? And now it's stopped. And obviously the Puppet-Master has little peaks too that correspond with that. So if you want to actually see that this is happening visually, Vagrant lib Vert, not VirtualBox crap, with Vert Manager and Version, all these tools, great environment.
When you say the Puppet-Master is a function of that as well, I understand what you should be showing is that one node picks up action on another node and that picks up additional action.
Can you repeat the last part?
Sorry?
Can you say the last part again?
Are you connecting to Puppet-Master in all those cases, or the agents are calling each other only? Because you're responding back to Puppet-Master, but it should not be the agent who's going to.
Correct. So the Puppet-Master technically doesn't need to be in here. The only reason it is in here because I'm running them under a master, but all the coordination is between hosts. The Puppet-Master isn't involved. But every time Puppet runs, it is actually asking the master. So that's because that's an implementation deal of Puppet, but it's not necessary for this technique. Okay? What else I want to tell you? Right, so there's a few other features in this poke module that you can do. So let's say a cluster wants to tell something to open. So what you actually can do is say we're all members of a cluster. We're going to have some common UID, say, volume X. And they can all poke one thing, perhaps, and that thing can wait a certain amount of time for all the pokes to come in. Because if 4 people poke and they all line up, you're going to have that thing run unnecessarily. So you can actually, the receiver can actually batch the pokes so that if 4 happen at the same time within 5 seconds, it will say, okay, all these 4 want a Puppet run, we'll wait and we'll run it all together. There's a few other little optimizations and things like that that make the threading of the Python program very tricky. Some gentleman has actually tried to write it in Go to make it simpler, but it's still hard. So if you're a threaded guy and can make this code better, please do, because it's terrible. It's got some races or something, I'm sure. So it's more for a proof of concept. The real multi-threading stuff I leave to the experts. And actually it's all done now, so it's run all its things. So that worked. Good.
What was that?
It was very strange.
It was very weird.
Brilliant.
It was kind of amusing.
Yes, it was rather funny.
It was incredibly funny.
I loved it.
You know those guys? Sorry. If you have feedback, we can ask questions. If you have feedback, please run this command and give me some good rating or something like that. Radek has been nice to, and Red Hat has been nice to pay to send me here. So if you like this and you like these techniques, please let me know. You can find it on the schedule too. You don't need this link. If you click on my talk, there's a feedback link somewhere. If you have questions and stuff, or you want to review some of the other techniques, we have some time actually, so we can go do some again. Yes?
Question, have you considered using M-collective as like a backend for this like nice logic?
Yes, so.
I mean the network model is kind of weird, you know?
Yes.
Like forking the Python script.
Right.
Because I've seen Rai kind of guy doing the M-collective. He's actually done like, similar things.
Yep.
Using the M-collectives, one too many. Yes.
So the question is, can you use something like M-collective instead? Absolutely, you can use something else. So I'm doing the simplest thing that's available on every machine, which is a Python script and SSH to actually connect. You could, instead of using SSH, you could use some messaging bus, like I think ActiveMQ or RabbitMQ or whichever the cool one is this week. You could use something like that to pass the messages. For the forking part, you still actually need 2 things. You need, on the server side, something to double fork away from the Puppet process. So that doesn't go away. You need that because you need to get the command line of the thing that started Puppet, so you know how to run Puppet. And on the client, your client program also needs to double fork if it's going to be async. If it's sync, it doesn't double fork. So you can't get away with without the forking, but you can get away without using SSH. You could use something else, and if you want to port this module to use, your favorite messaging queue, please do. So yes. Any other questions? Yes.
I would have kind of similar one.
Yeah.
Might be.
You work for Puppet Labs.
No.
Oh.
I just do the teacher.
Cool.
And might be. I was just thinking about what you do with this popping, and I was thinking that it might be a good idea to just write a systemd unit.
Okay. For the script.
Instead of the Python script, I can just use Puppet to deploy a new systemd unit that will actually watch something, and whenever something happens, it will run the Puppet.
So his question is, can you have Puppet deploy a systemd unit that will do this? If you can, please do. I'd love to have this patch. The reason I think you cannot is because for the server to actually know how to run Puppet again, the way I do this is Puppet itself first runs and starts the server. And in starting the server, it's forking away a thing, and that child process can read its parent's command line. So it knows how it will run. So that's important because you don't want to just arbitrarily run Puppet however. So if in your solution you can somehow get the parent command line so that you know exactly what Puppet command to run, then yes, you can do that. So it's a great idea. I'd love for that to work. If you can make it work, I'd love to see it. It would be great.
So one thing that is actually a bit better in the system proposes is that while your forking thing can look into the command line and write down somewhere a configuration for systemd unit, actually a timer, because systemd has support for timers, for things that delay for run.
Right.
If you run a configuration and store a configuration of the options that Puppet was run with.
Yeah.
Then you can schedule a systemd timer to run with exactly that configuration.
Okay.
And the thing is that systemd has a templating system where the service or socket or timer can be templated based on the parameter you pass after at.
Right.
So you
could do it.
You could do it in a generic way.
Yeah.
So you have a single script that basically writes down the configuration of Puppet runnable options.
Yeah.
And then use that.
It sounds like I'll repeat the question. AB has volunteered to send me a patch to do this with systemd. But absolutely.
We can work on that tomorrow.
Absolutely. Yeah. So it could work perfectly. So this stuff is fine probably for production, real use cases today. If you use these hammers for every problem, then you're doing it wrong. In most cases, you really don't need these hammers. Okay? But if you really do, then they can be useful. At some point, the Puppet language and the way it's structured, the fact that it's not very dynamic, might be a problem. So I think what's actually going to happen is in the future, somebody smart who wants to do a startup, hint, hint, is going to write a new generation config management language that's event-based, that's parallel by default, and does other things like that, where these techniques would be just at home natively. So since such an engine and language doesn't exist right now, I'm building these on top of Puppet. But if Puppet Core doesn't eventually grow these features, someone for sure is going to build this in. And if you don't believe that that's going to happen, there's all sorts of people annoyed at the static nature of config management, and they're trying to do like pseudo orchestration with Kubernetes and similar things like that. And it's very dynamic, but it doesn't have much config management. So there's probably a middle ground for what that would look like. And if you want to talk about that more, I'm Purple Idea on the internet. So yeah, there's definitely, I mean, this is not a dead space. Containers are not going to kill config management at all. But we need to innovate still. More questions? Who has it? You had a T-shirt too. AB. I think about some T-shirt. Yeah, question.
Question: do you think some of these problems, like the global state of the configuration, could be also solved by, service discovery systems like etcd or console or something like that? Part of the problem, where's the global config state of all of it?
So you asked if these systems can be, if these problems can be solved with service discovery and other things. Some of these problems and the solutions do overlap with service discovery. And service discovery can, by itself, solve a lot of problems. etcd and a distributed key value store can also solve a lot of problems. It's not a full intersection, though. So we do really need, maybe it's only 20%, but only for certain complex clusters, need some hybrid solution of the two, right? So Puppet's over here. Over here is like etcd and console and stuff like that. In the middle, there's a really nice solution that I have in my brain, but I don't have time to write. And then as a proof of concept, somewhere closer to the Puppet side is my hacks. Right? It's not perfect, but it's trying to show that this exists and it's viable. What do I want to tell you? What I would like to know, maybe someone's an expert, is like how to scale something like etcd or a distributed key value store to hundreds of hosts or thousands of hosts. Those are open problems that I'm not the expert in. But if you know those solutions and you say, yeah, I got a 1,000 host distributed key value store, come check it out. Let me know. Those are problems that need solving.
Well, I talked to Mitchell, on the configuration tab, and he insisted that it can be used up to 10,000
console?
So
For the key value store too?
Yes.
Oh, so maybe it's all. I'd love to know if that's all. I haven't experimented with. I only have 8 gigs of RAM, so my limitations are. If anyone work for Lenovo, tell them to stop making the nice laptops with only 8 gigs of RAM. It's a stupid idea. Any more questions? I'm happy to answer questions. I have all sorts of other weird techniques that I talk about on my technical blog. Some of them are harder to demo and show in a presentation, but you might like some of them. I'm happy to ask questions about those things too. Any questions? Do you want to see anything again? Yes? You were like nodded.
Yeah.
Which one? Some more? I want more. Let's see what we have. Did you like this? You like this? Okay. Yes. 15 minutes. So we have shown you all this stuff. Well, we can talk about a few more techniques if you want. This is my favorite website. Cheap plug. So I've actually made a Puppet tab with all sorts of different Puppet techniques that you might want to look at. So here's another distributed technique. So some operations in Puppet, you can read about these, but if you want to talk about it briefly, some operations in Puppet you might only want to have run on one host in the cluster at a time. So in order to make sure that Puppet doesn't run the same command twice, you can actually just use something like keep alive-d or anything that provides a unique token. And before you run on the cluster, you actually check, is this virtual IP present on this machine? If so, I can run. And the reason you would want to do this is because if you have a distributed system where the software needs to run some commands, you want to make sure that it's not two people running that same command at the same time. So that's a little quick hack you can do. I've got code for that. Okay, we have 15 minutes. I know what we're going to do. Oops. Have you seen the steam locomotive? You can't kill it. It's where is it? Okay, I'll show you this quick talk I gave. Okay, this is the wrong presentation. This is just a thing that I think you might like. Blah, blah, blah. Okay, so this is really quick, random impromptu bonus talk. Yeah? Some applause? Yeah, bonus talk? All right. Okay. Cool, thank you. Cheer me up a bit. So this can be used for containers too, side plug. But this is a really good idea, I think. And, I wrote this for AB actually, or CMO, so CMO wouldn't kill me, but to keep the free IPA guys happy. So here's who's written some Puppet code like this. Come on, don't lie. I won't beat you up. Who's written some code like this? Come on. All right, I've done it too. It's okay. Hi, I've done this code. Is this a good idea? No. Is it a bad idea? So it's not a good idea, okay? Really not a good idea. Okay, but some people said, it's okay. I know about one-way hashes. Who's written some code like this? Oh, I've written code like this. I probably still have code. Anyways, this is a little bit better because the password is at least hashed. But is this a good idea? What? Is this a good idea? Do you want to see the next cat picture? Okay. It's really not a good idea. Okay? But there are people all over the world that are still doing this, right? They're putting their passwords, even their hash passwords, in Git repos. Public Git repos even. You can go like clone other people's machines this way. You can use Google to find these passwords. It's incredible. But then the Hira people, have you seen Hira? It's a way to store data separately from Puppet, and it's a really lovely thing, and I love it, and so on. But people are like, it's a separate repo, so they do something like this. Is this a good idea? Nope, it's really not a good idea. And why is this? This actually is a worst idea. Which is the best one? I think, which one? 1, 2, or 3 of the best of these three? 2, right? Because 2, it's at least hashed. 3, it's a disaster. So these are not good ideas. Now, there are some solutions to these problems which are better than others. Does anyone know of some of the solutions?
Yeah.
YAML. Right, so let's go through them. So there's the first one that's called Hira GPG. It's actually, you can look at the code and see some rants about it from 2003. Basically the problem, the way they solve it is quite simple. They take a public and a private GPG key. They encrypt the secrets with the public key. So the system encrypts the secrets and puts them in a Hira file. And on the server has the encrypted file and the private key. So when they want the secret, you have the plain text, right?
You spoke about private key twice. Where the public key?
I'm sorry. So you generate a key pair. The sysadmin has them. He puts or she puts the private key on the server along with the encrypted hash or the encrypted blob. The public key is used by the sysadmin to encrypt it. Right? or to edit it or whatever. So you put the private part and the encrypted part on the server, so that technically, if you just have the Git repo on the internet, it's all encrypted and no one can see what you have. But what's the problem with this? What? Yeah, you have to have the key on the systems, and if you have the private part and the public, if you have the private part and the encrypted part on the server, your server gets pwned, you have the clear text. So it's kind of stupid. And as you said, you have to manage the key. So there's a slightly better one that's actually identical in functionality. 10 minutes? Yeah, we're good. Called Hyra-YAML. I even met this guy. I showed him this technique, and he came up, I talked about this, and he came up after, he was like, this is a really good idea. So this is the same thing, but there's some nice code to edit the YAML files. So it's slightly better, but you still have the same problem having the clear text and the encrypted bit together, so you can still pwn your machines. There's a third one that I'll mention called Black Box. The guy who wrote this one writes a lot of books and is famous on the internet or something. And I give him credit, actually, out of all these three the most, because if you read the documentation, he actually tells you about this problem. Right? It's not a secret, it's not some hand-wavy, so if you don't really understand the encryption, he's at least honest and warns you that it's a little dangerous. All right? Any questions? So, do I love any of these solutions?
Yes, you do.
Oh, you don't.
They brought you to the right one.
That's true, they brought me to the right one. Oh, well. Do I love them as they are? Nope. I really don't. Have you seen this guy? He's my, nope guy. So, it's a ion cannon. It's you have to nuke it from orbit. It's the only way to be sure. So that's the guy. So here's my solution. So you're all good admins. You all have GPG keys, right? Because that's how you all send email. Come on, make me happy. I have my GPG key here if you want after, just the public part. So what you actually do is, if you want to have a secret on a server, what you should do instead is generate it on the server. So the server that boots up, it will have pwgen or whatever command, generate your own secret on the server. In addition, put your public GPG key in Puppet. It's public, it's already on the internet, it's not secret. And on the server, just before you use the password in your software, run it through your GPG key, encrypt it, and send that encrypted blob by email to yourself. If you want a copy of the password, that's how you'll get it in your inbox. If you don't want a copy of the password, then it just stays on the server and it's not used at all. And this way, the secrets are all automatically generated, and if you need to destroy something and rebuild it, you can just regenerate it. Now, how do we build out our infrastructure? To build out your infrastructure, you can actually make it very easy by first generating a free IPA, which is LDAP and Kerberos server, that uses this technique and sends you the master passwords to your email. And after that, you can use that to authenticate everything with Kerberos so that no passwords are needed, or very few. And this is basically how you solve this problem. It's all generation. So at the end of the day, the sysadmin only has one password, which is maybe a backup of their main directory manager password. Do you like this idea? It's actually quite simple. It's not hard. I wrote a Puppet module for free IPA, which is actually, if you don't use it, it's really good stuff. And I was using it before I worked at Red Hat, so I'm actually unbiased on this matter. And it's true. And AB helped me a lot, actually, because figuring out LDAP stuff and internals is kind of tricky. And so I built this technique for this module. So if you want to try this out, run the code. I'll generate that for you. And it's all automatic. Any questions?
So I guess that the security concerns are the reason why you did not use the most popular
Hyra-YAML. Yeah. Right. Yeah, because it's all your secrets are just encrypted, but they're visible to the server, right? Your server might get pwned. And if it gets pwned, they have all your secrets.
I spent about 3 days trying to figure it out.
Yeah. So don't use that stuff. The only reason I would really use Hyra-YAML is for a really legacy infrastructure that's not migrated to secure secrets yet. And in transition, if you really have some public Git repo, fine, do it. But I don't think it's the best solution. So it's actually a really simple solution, but I think you should use this for all your infrastructure. And if you want to see some example code, it's all in my Puppet-IPA modules. Cheap plug from my other talk. Red Hat pays me. It's nice that they pay me. If you want to email my boss and my boss's boss, who's Red Hat here, by the way? Who's Red Hat and who's not? Ah, that's good, good. I don't want this to be like there's too many Red Hat people here, right? But we have some good hackers. So this is some links about the technique if you want. I am Puppet-IPA at Red Hat, Twitter, my blog, and all that stuff. This presentation you can find on my Twitter if you want the slides. And the presentation I gave today, I will tweet something if you want. So that's it. Thank you very much. If you want a t-shirt, come here and grab your t-shirt. Oh, you had a t-shirt, right? My other talk, there'll be more t-shirts if you want, and it'll be less painful, I promise.